Neuroprosthetic rehabilitation. What we're kind of referring here is like you're taking an animal which is suffering from paralysis, and you're taking every tool you have in the chest and you're throwing it at that animal in order to rehabilitate them. In effect, potentially finding a treatment, or I don't want to use a cure because it's not a disease, but a treatment to reverse the effects of paralysis. You'll understand why in a second. However, it is just a fascinating study, mainly because also, I should say, is that the body does have the ability to rewire itself. So in this research, without preluding it too much, you're actually not working at fixing the damaged nerves. You're actually basically from the brain to the area which is damaged, drawing up all new connections through this intensive type therapy. So let us begin and proceed as follows. It's, again, incredible results. But to proceed, paraplegic rats walk again after therapy. Now we know why. All right. Also, before I proceed, you hear, for example, animals. Well, the benefit to this is as follows, that humans have greater brain plasticity than rats or rodents do per se. So there's a possibility that humans may even respond better or faster to this particular type of therapy. But to move on. It says the therapy triggers the growth of new connections from the motor cortex into the brainstem and from the brainstem into the spinal cord, thus reconnecting the brain with the spinal cord below the injury. The results published in Nature Neuroscience is March 19th, 2018 in Carteen's lab. I hope I'm pronouncing that correctly. Rats with a contusion that leads to complete paraplegia learn to walk again with the help of therapy that combines electrochemical stimulation of the spinal cord and robot-assisted rehabilitation. The rat's spinal cord is first stimulated with pharmaceuticals, then electrically stimulated below the injury to activate the muscles in the legs, combined with therapy in a smart harness that alleviates the body's weight, providing natural walking conditions. And here's the cool part. And after just a few weeks, to reiterate, a few weeks of training, the rats regain extensive control over their hind limbs at will, even without electrochemical stimulation or the harness. Now to proceed, how this may apply to people. It remains to be seen if people lead to analogous rewiring of the brain, brainstem, and spinal cord. However, Corteen, the researcher, is optimistic, and to quote, "We previously showed that plasticity, the remarkable ability of the nervous system to grow new connections after spinal cord injury, is even more robust in humans than in rodents. We are currently testing our therapy in people with spinal cord injury at the Lausanne University Hospital," end quote. So that's an amazing, I should say, hope for a lot of individuals which suffer, I don't want to say suffer per se, that have or are injured through paralysis or whatever. But again, through extensive brute force type treatment, using every tool they have in the chest, at least in this case, the animals recovered. Now to see if humans respond even better. I hope you find this information of use. I found it fascinating. And I look forward to seeing you all again in 7 days. And thank you very much for listening. Catch you then. Bye.